You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to Seen and Solved, presented by Hubbard-Hall. I'm Tim Pennington, your host. Again, today I'm talking with Jameson Grout from Hubbard-Hall, who's has been out in the field for the last couple months since he joined Hubbard-Hall, and he's seeing a lot of issues and a lot of problems that crop up. And luckily, thankfully, I should say, he solves a lot of them. And the one we're going to talk about today, I'm not very familiar with, so I'm looking forward to this because it's going to be pretty interesting, is the Woods nickel strike. So, Jameson, first of all, thanks for joining us today again.
Thanks for having me.
Yeah, great. Woods nickel strike. Tell us about it. Tell the people that may not know. Tell us a bit more about that.
Yeah, so strikes, very common in our industry, necessary to the process. And there's some really good articles online, so we're really not going to talk about how strikes work. Really what we're going to kind of focus in on is when they're not working, and how do you know they're not working, and what are some things to try to do to stay on the front end of that, right? So we'll talk about some customer visits, and we'll talk preventative medicine. So strike tanks they're there to help your adhesion, right? We have some base materials that don't want to receive the plate, stainless steels, high nickel alloys, exotic stuff. So these are kind of passive surfaces that we need to overcome. So that's actually one purpose of the strike. The other purpose of the strike is actually to collect tramp metals that you want to keep out of your plating bath, right? Especially in decorative jewelry, right? Like your gold strike is helping your gold adhesion, but it's also preserving your $200,000 gold tank, right? Keeping the bad metals out. So that's why it's important to take care of it. I don't think it gets a lot of attention. It's not flashy. It's a functional intermediate step. And, from the supplier end, there's no brighteners. There's no expensive constituents. There's not a lot of, there's nothing to really be gained from it. So I think a lot of people it's put on the back burner. They don't really think about it too much. It's fallen in our camp of processes that get ignored. So.
Well, I was going to ask you that. I mean, how many do you see regularly do it? How many do regularly do it and keep up with it, do you think?
So it's not on every nickel line, but you do see quite a few. And a lot of what we do see actually is that people plate, and then they have an adhesion issue, and then they go back and they just dump the strikes and they start from scratch. And honestly, that works for a lot of people.
Right.
We're just talking hydrochloric acid, nickel chloride, easy makeup, easy to keep on site, stuff you may have for other tanks. So that's an easy option for a lot of people. I don't like that because I want to know when defects are coming. I don't want to be reactive, and I don't want my go-to answer to be, let's just dump the tank and start.
Just jump it.
I haven't learned anything, and I can't prevent that from happening next time. So what we see a lot, someone calls up, my nickel adhesion's bad. And, we'll come out, we'll start looking at things. First thing I like to do is whenever I have blisters or peeling is tape test it. But even if I know it's going to fail, what I'm looking to do is, get some tape on there, pull it off with force. And then I want to look at that underside. I want to see where is this failure. And sometimes you can just tell visually, right? Like you've got your stainless and it's nice and shiny. This Woods nickel strike is going to be pretty dull. And then your nickel on top of it may be dull too. So if you're ripping plating off and you're looking at stainless, then I can say, okay, my strike failed. That was my issue. But sometimes that strike's adhering and it's your plating layer that's failing. And then that's, a different conversation. So I think today we'll zoom in on that failed strike adhesion and see what we can do to prevent that from happening.
Okay. Well, go right ahead. I mean, what are some things that what are some preventable things that you would suggest to help with that?
So I think the first problem that we see is nickel growth. And so, you get a call, we got adhesion problems, you come out, you tape test it, okay, the strike is not sticking. And once we know that, first thing I want to do, let's analyze this tank and see where's this nickel content. Because the nature of the strike, it's a low metal, high current process, and that's why it works as good as it does. What can happen is that nickel can start growing, And then once you get to a certain point, now I don't have a strike tank. Now I have an inefficient plating tank. And that is not providing the activation I need on that surface. So how does the nickel climb? If you're not viewing the strike tank as a process tank and you're not titrating it, you may not see it growing, but it could be growing from you leaving the anodes in. So I guess we'll sidebar. We can talk about what nickel you should be using in the anodes. So plating tanks, we like S rounds because they dissolve so easily. Now, where I don't want my nickel growing, maybe I don't want S rounds anymore, right? So we usually recommend people use the solid bars, just rolled depolarized nickel slabs. Another problem with the S rounds is you only have to put those in a cage, and titanium doesn't always love this environment, high acid, high current, going through it in that direction. So I like to stay away from cages. I like to stay away from S rounds. But I had a shop up here in Massachusetts who was actually really struggling. And what they had to start doing was every day at the end of first shift, they actually got the hoist over and they had to pull all of their nickel out of the tank because just leaving it in the tank overnight was getting them in trouble.
It was causing problems, yeah.
Problems, just growing every night. So they got some buckets right there. They'd rinse them off. They'd stick them in the bucket, and then they'd start the lineup the next morning, and they'd turn all the rectifiers on. They'd turn the temperatures on, and they'd put the anodes right back in the tank. So that's an option for some people. But really, I think what we see a lot too is people barrel plating. Maybe you have an acid tank hydrochloric before the strike, kind of activate that surface before you come in. That could be dragging a lot of acid in. So if the acid's climbing, now the bath's more aggressive. It's attacking the anodes more. Now you're dissolving more nickel. So pretty common problem there.
Is this a complex thing to do for people? Like I said, I'm not sure. Is it something that's maybe too complex for people to do, or is it shouldn't be, or it's not?
No, it's really not complex. I think it's just kind of I don't want to say we take it for granted, but it's not the flashy process tank. It's not the focus of the operation. So I think we don't check it, or we just dump it when it's a problem. It's just like one more thing for the lab to maintain, kind of thing.
It sounds like you're seeing a lot of these issues and able to solve them. Give me another one that you might be seeing that people should be made aware of when it comes to especially adhesion problems and things such as that.
Yeah. So if we come out, we're failing tape test, but then say we look at the bath and the nickel's good and the acid's good. I think the next most common problem is metallic contamination. So it's kind of the point of the tank, right? Because we're trying to keep these contaminants out of the plating tank, but it means we're still building contaminants. So I would like to keep an eye on it. What we see probably most common is copper, and that's always the boogeyman of a plating process, right? Because copper wants to create immersion deposits so readily. You're in an acid environment, so we see it on a lot of hardware, a lot of contacts, a lot of bars. So there's always copper in the environment. And this is where it's going to give you a problem. It's going to undercut that nickel, and it's going to give you a failure. Good thing about copper, you can dummy plate it out. So, some shops will implement some sort of PM schedule, dummy, every weekend, every night. Everyone's a little different. I've always been a fan of what they call it, corrugated sheets. Yeah. So then you get the highs and the lows. I think that's the best way to do it. That copper is going to come right out in those lows. But iron is another one that you can't dummy plate out. So iron will be growing throughout the process. And actually, I was out in Eastern Mass a few months ago at a place, failing adhesion, and we were checking, and they weren't doing any sort of metallic analysis. So they were actually on top of the concentrations. Everything was good. We sent out a lab sample, and the iron came back at like 2,000 ppm. And strikes, there's not a lot of great resources on how to maintain a strike. You can look up formulas, and there's debate, as the ideal formula, but there's not like a great concrete list of this is your dump point for metallic contaminants. So it's something that's a little different place to place. But to me, like, I don't want to be over 1,000 for iron ppm. I don't even want to be over 750. That's where I would start questioning things. So these guys are 3 times over where I was comfortable. So
yeah, I was gonna say, what do you do at that point then when you're at that high? What's the kind of the first step that you want to do with that?
at that point, you need to decant. That's the only way to get it out. And unfortunately, when you get that high, you got to dump that whole strike. That's why if you keep eye on it and you never go over 500, you pull out 20% of the tank and kind of bleed. That'll keep your quality more consistent. That number is kind of in the same ballpark, and that'd be my preferred approach. But once it gets over 1,500, 2,000, then it's kind of, it is what it is.
Yeah, it is. It's kind of beyond repair on that. Any final thoughts or tips about Woods nickel strike that you want to impart with us here?
Yeah. This is a higher current process. That's kind of inherent to the way the whole system works, low metal, high current. So whenever we're talking higher current, I always like to kind of zone in on the connections, the electrical connections. Very common issue we see with, especially a Woods nickel strike. You've got a lot of hydrochloric acid. That area around the tank, it's very corrosive. Those eyelets on the back are going to see a lot of attack, especially if you're running barrels. You're going to be dripping nickel all over things. It's going to eat away at your equipment. So I know I was involved with a company doing some NADCAP prep, and they had gotten drilled pretty hard by the auditor on a previous inspection because they really weren't maintaining their electrical connections. And especially on that strike tank, they had actually gone ahead and encased everything with shrink wrap, and they really went above to protect those connections, because you start seeing drops on the rectifier, and once you're not getting the current you think you're getting, you're opening the door to more failures.
Interesting. Like I said, well, I appreciate that. A lot of good information on Woods nickel strike. Appreciate you giving us all that. By the way, I congratulations to you. I know that you've placed Bill Navolio of the Connecticut NASF Chapter, the secretary, correct?
Yeah. Yep. So Bill's handing the gavel over. He's still going to be involved. He's still kind of mentoring me through this, and he's going to stay on, be active as a technical advisor, and he's running all the speakers and stuff. But I will kind of be stepping into that role and trying to keep the chapter going and try to grow it a little bit.
Bill always puts out a very nice newsletter that puts all the great information. If you're up in that Connecticut area, it'd be great to kind of, if you're not a member of that association, you definitely want to reach out and see about information, because they always have a very nice the meetings always have very nice topics and things like that, timely and everything. So, but congratulations for taking that over and running that. You got big shoes to fill, but I'm sure you'll be able to do it.
I definitely do.
Yeah.
Thanks, Tim.
Yeah. All right. Thanks again, Jameson. Thanks for joining us and giving information on the Woods nickel strike.
Anytime.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.